Okay, so today what we're going to do is we are going to look at how to calculate angles using trigonometry. You've already done this in the past when you had to calculate the angles when you had a slope. So if you had something like this, and then you had, for example, that this was 100 meters and this was, I don't know, 70 meters. Okay, and we wanted to calculate the angle of elevation here. So in the past, what we've done is we've said, okay, we know that what we have here is the rise and we have the run. Okay, and you know that the tan of any angle theta is equal to the rise over the run. So we were able to fill in those details. So we were saying the tan of theta equals 70 over 100. And then what we talked about in the past was that theta is then the inverse tan of 70 over 100. Okay, and you can calculate what that comes to using your calculator. So we can put that into a calculator. Unfortunately, I don't have a school calculator with me at the moment, so we're going to have to use this one. So we can go shift and then tan, and in there we're going to put 70 over 100, which gave us the answer of 34.99. So theta is approximately 34.99 degrees. Okay, actually typically we do tend to round to 1 decimal for angles, so what we would say here is really 35.0. So it is approximately 35.0 degrees. All right, so this is what we've done before. What you also learned in the last couple of lessons is what to do when it's not in a nice rise over run situation. Okay, so for example, when we have a triangle that looks like this, let me just make it a shape. So we have a triangle like this one. We could say theta is here. We have 5 centimeters here and 9 centimeters here. So in the lessons that we've just done about sides, you learned about saw, car, toa. And we're going to use that again here. All right, so if we want to know that theta that we've marked there, we need to firstly think about what these sides are in relation to this theta. Now, from the angle theta, the 5 is directly opposite it, so we're going to label that side with O for opposite. What you can also see is that the 9 centimeter side is opposite the right angle. That makes that the hypotenuse. So if we have O and H, then that means if we look at our 3 ratios here, saw, car, toa, we are using saw. So that means our formula is going to be the sine of theta equals OH, so opposite over hypotenuse. We can now fill the numbers in. This works exactly the same as it did for tan. Okay, so we have the sine of theta is equal to, the opposite was 5 and the hypotenuse is 9. So theta is then going to be the inverse sine of 5 over 9. Right, we're going to throw this in the calculator as well. You'll see that the calculator here says arctan and it's going to say arcsine as well. That's just another notation. Your calculator won't do that, so don't worry about that. So what we're going to do is now shift sine 5 over 9, and we get theta. This should have been equals, not approximately. Theta is approximately equal to 33.7 degrees. Okay, so this is how it works for calculating sides. Obviously, in this case, we had O and H. Sometimes you might have the adjacent side and the hypotenuse, or the opposite and adjacent. So you use the appropriate ratio for whichever one. But that's it.